Hi all, I am discussing a topic in thermal radiation, which is view factor. Basically, this is for students who are in +1, +2 area, and they were doing problems related to multiple surfaces transmission of by radiation. In the process of doing this topic, view factor is a higher order level, frankly speaking. But it is a tool that can be useful so that the student can do easily whatever the problem that he is aiming at. When I am speaking about a view factor, it is purely a geometric quantity. When I am speaking about view factor, it is independent of surface properties and temperature. Some people, in some books, the same view factor is also referred as shape factor, configuration factor, angle factor. Fine. What exactly is view factor? See, I will represent a view factor like this. A term F, some I to J. What exactly I am representing here? The fraction of radiation leaving the surface I that strikes the surface J directly. I repeat, it is defined as the fraction of radiation leaving the surface I that strikes surface J. I'm speaking something about a ratio. You should take a note here. See, the radiation that strikes a surface does not always need to be absorbed by the surface. Or in other words, radiation that strikes a surface after being reflected by other surfaces is not considered here. I'm repeating two important notes here. Radiation that strikes a surface does not need to be absorbed by the surface. Radiation that strikes a surface after being reflected by other surfaces is not considered. Now, I am speaking, I refers to some surface like this. J refers to some surface like this. We are speaking like this. See here, certain theories, certain theorems is a must for you, without which you cannot do. Like for example, when you are solving some circuit problems, network problems, as a circuit, you will use some network theorems. Likewise, I am giving you some theorems, two theorems. One is reciprocity relation. See, in this reciprocity relation, what I am going to tell you is, suppose if I am telling you that this is area 1 and say this is surface 1, this is area 2 and this is surface 2. What reciprocity theorem states is A1 F12 is same as A2 F21. Don't forget what is F12. Fraction of radiation leaving one striking 2. Similarly, A2 into F21, fraction of radiation leaving 2, striking 1. See, usually view factor ranges between 0 to 1. For example, f I to j is equal to 1. I am saying like this, which clearly indicates j completely surrounds I, like concentric shells, long, infinite long concentric cylinders. For example, if f of I to j is 0, the two surfaces do not have a direct view. J can never see what is I can never see what is j. Likewise, sometimes same surface F11, radiation leaving 1 may not strike 1 again. So F11 is 0. I'll tell you examples for later. So when I'm speaking about view factor, please remember the radiation that a surface receives from a source is directly proportional to the angle, I repeat, the angle the surface subtends when viewed from that surface. I'm speaking about suppose A1, A2, if you are taking the angle here. On that basis only, this reciprocity relation was derived. This was derived. So at higher states, like in BTech program and all that, you will anyway learn this. But the mathematics involved is too lengthy. A page and a half solution is involved in this. So I am simply giving you the matter of fact, this is reciprocity relation. On the other hand, the radiation coming from source is when I am doing this, I'm assuming the radiation coming from the source is uniform in all directions throughout its surface. And the medium between the two surfaces has nothing to do with this. I mean, it should not absorb, emit, or scattered. Such cases are called non-participating. Remember, reciprocity relation is one tool to solve. The other tool to solve the same is summation rule. Summation rule. What is the summation rule? Suppose you have some surface like this, and this is a source. So I imagine that these are all n different closed boundaries. So sum of the view factors from surface, say I, of any enclosure to all surfaces of the same enclosure and remember, including itself. Must be equal to unity. Means sigma Fij is 1, which means suppose if there are n surfaces, F11, F12, F13, so on, F1n is equal to 1. With these two theorems, reciprocity relation, summation rule, I am going to do maximum problem. That's all. This is the only information I got. Meanwhile, just want to propose you this. For example, it's a plane surface. I have the source here. So you have radiation diffusing in all the directions. In this case, F11 is 0. Suppose you have a convex surface. I'm speaking on the top. Here is the source. Then again, the same diffusion, F11 is equal to 0. Whereas the source is here, the concave side. The concave side. Then you are not supposed to write this relation. In this case, F11 is not equal to 0. And I can't say 1 because whether it is closed or not, no idea. But these two, I am very sure. So I am going to use these relations, reciprocity relation and summation rule. For example, if I am using the same in case of a concentric shells, I am speaking about concentric shells here. You have concentric shells here. For a while, let me consider this is some radius A and this is some radius B. I will call this as 2, this as 1. Now please come back. Now please come back. Here, F11 plus F12 is 1. We already know F11 is 0. I told you here on the basis of this rule. F12 is 1. Good. Now use reciprocity. A1, F12 is A2, F21, which clearly indicates A1 is proportional to A square. F12, 1. A2 is proportional to B square. F21 is what I require. So therefore, F21 is A square by B square. What exactly that means? Suppose if sphere A only A I am drawing. Suppose if A emits a radiation, A receives A square by B square times sigma 4 pi P square TB power 4. Whereas A emits sigma 4 pi A square TA power 4. This is how I have used. Now, by the way, I said F21 is this. What about F22 now? F22 plus F21 is 1. So therefore, F22 is 1 minus F21, 1 minus A square by B square. What exactly this means? Now you take only 2. Only 2. The 2 receives 2 things. 1, whatever that emits from here receives here. Sigma 4 pi A square TA power 4. Apart from that, the radiation emitted by B is coming back, returning back. What amount? What amount? 1 minus a square by b square sigma 4 pi b square tb power 4. This is receiving part. What is the emitting part? In this direction, it emits sigma 4 pi b square tb power 4. Similarly, sigma 4 pi b square tb power 4. So this is how you need to understand the mu factor. Next problem onwards, I won't even say, I'll simply say that A receives this much from B. Similarly, B receives two things directly from A as well as its own back part. This is a very important proof for you thereafter. On the basis of which, I am going to construct a question now. I'm going to give you a question now. The question is, this is some enclosure. This is sphere 1, sphere 2. Don't worry, I'm for my geometry purpose. Well, this is my picture. You can see whatever the information given to me is, both are highly conducting shells. Both, without this, you cannot start. Both are highly conducting shells. And they have radius R and 2R. Right. It was given, this is A, this is B. Temperature of A is maintained at 2T naught. Now this is the enclosure. The enclosure temperature is a T naught. In steady state, what is going to be the temperature of B? In steady state, what is going to be temperature of B? That's the question. Fortunately, here the absorption coefficient of B is 1. Whatever that comes from A, it absorbs without any compromise. There is no fractional part in that. Well, how to handle this problem? Now, my entire focus is on shell B. See, I am just showing only a portion of this. So what exactly shell B receives? Shell B receives directly from A sigma 4 pi R 2T naught to the power of 4. Right? No. Apart from this, I am assuming the temperature of this as a TB. Now what will happen? 1 minus R square by 4R square, which means 3 by 4th part it will receive again back. Don't forget, we got the expression here. F22, F22. This is 2, this is 1, for example. F22 is 1 minus R square by 4R square. 3 by 4. So it receives 3 by 4 times sigma 4 pi 2R square TB power 4. So received is this. Here it receives one more thing from outside. Sigma 4 pi 2R square T naught power 4. So input contents are this. Now what about the output? Now this radiates sigma 4 pi 2R square TB power 4 sigma 4 pi 2R square TB power 4. So with this, I'll conclude 2 times sigma 4 pi 4R square TB power 4 is here. I'll conclude here sigma 4 pi, don't forget here it is R square, 4 pi R square 16 T naught power 4 plus sigma 4 pi, here you see 4R square again, 4 T naught power 4 plus this one. This 4 gets cancelled. 3 sigma 4 pi R square TB power 4. Dear friends, by solving which you can say that TB is simply TB power 4 is simply 4 times T naught power 4 implies TB is root 2 T naught. A very good model. See, only one step. What is that you need to understand is what is coming in, what is going out. Remember, this is at steady state. Remember, everything is absorbed. Suppose only a portion of this is absorbed. It's a very complex problem. Fortunately, they are conductors. They are not FZ. It's like whatever you give, whatever it radiates, everything is fine. Next model, a similar model, which I am going to give you. The model which I am going to give you is now 3 concentric spherical shells. Previously, we dealt with 2. Now I require 3. 3. Now you imagine these are 3 conducting shells, right? So I am giving them radius values. One is A, the other is B, the other one is C. I hope till this point there is no issue at all. Now, what is happening here? The problem is that by some means, in the innermost shell, there is a heater of constant power. and that power is P, power of the heater. Right? Now, all these are black bodies. You imagine all these shells are black bodies. Their of radius ABC, and they are kept in vacuum. And no medium, no interreacting medium between them. So inside the innermost shell, there is a heater of constant power. All these are highly conducting concentric spherical shells. Right? Now, what am I going to do with this? First, how the way I have done the previous one at steady state, I will take each shell. Now, I will take the equation for steady state equation for the inner shell, innermost shell. Now, it is difficult to draw free body diagrams, right? You understood by this time what is happening over here. See, what is received by A? Received, I will write left hand side. Delivered or emitted, by that I'll write right hand side. Received, I will write with in the left hand side. You are receiving power P from the coil. Don't forget F. What is this? F21. For these two combinations, F21 is A square by B square. So A square by B square. Don't forget. I told you clearly. A square by B square of this. A square by B square. Sigma 4 pi B square TB power 4. And this is equal to sigma 4 pi A square TA power 4, equation 1. For the innermost shell. Only one surface for the innermost shell. Don't take the inner side. So the radiation which you are measuring is the outside part. Next, the middle shell now. Middle shell. Students, middle shell part. Now sigma, what is received by the middle shell B? Whatever given out by A, F1, when F11 is 0, but F12 is 1, means whatever emanated from A is received by B. So sigma 4 pi A square TA to the power of 4 plus allow B, whatever it emanates above the shell, within the shell, but only 1 minus A square by B square part is again collected back. Whatever given by B, out of this, this much is collected back. Don't forget, here is the proof. So therefore, sigma 4 pi B square TB power 4 is, of course, here I need to add one more. What is by C? C is here, B is here, A is here. C is also doing the same job as what we have here. So I should write this as B square by C square sigma 4 pi C square TC power 4. And this is 2 times sigma 4 pi B square TB power 4. My dear friends, let it be equation 2. And now the conclusion, not conclusion, the climax. The outer shell. Outer shell refers to 1 minus b square by c square sigma 4 pi c square tc power 4. Hope you followed. Whatever given by C, collected it back. Plus whatever given by B, it is absorbed by C directly. Sigma 4 pi B square TB power 4 is 2 times sigma 4 pi C square TC power 4. Equation 3. Fortunately, outer surface is vacuum. Nothing is there in the ambiguous part. Right? The surrounding part, there is nothing. So now I'll simply add all the 3 equations. You not trust me by adding all the 3. Or just believe me, some terms will cancel. Now you see, this part gets cancelled over here. Similarly, this part gets cancelled over here. Similarly, see, this part will get cancelled over here. Similarly, this part gets cancelled over here. After all such cancellation, finally, you will have P is equal to sigma 4 pi C square TC power 4. It's as same as now the shell A, how it behaves. Overall full solid C, if it is there, same way it behaves. Means C gives out in the same way. Now I got the temperature of C. Now substitute the temperature of C in equation 3. You try to substitute the equation part. Now I got TC, right? I got TC, right? Now I'm going to use TC in equation 3. See, you will get TB. You know what you are going to get? TB power 4 is P by sigma 4 pi times 1 by C square plus 1 by B square. Obviously, man, because 1 minus, right, you have this relation. Temperature of innermost shell is what my focus is right now. Temperature of the innermost shell. T A power 4 right? Or here when you get TB, substitute that over here. You will get TA power 4. TA power 4, you will get it as TA power 4, you will get it as, now you substitute this part over here. So TB power 4, you will get in TA power 4 as P plus C. Simply what I am writing is sigma 4 pi TB power 4 place B square cancel. Sigma, here is it, sigma 4 pi TB power 4 is simply P times A square into 1 by C square plus 1 by B square is equal to what we have is sigma 4 pi A square TA power 4. So with this you will get TA power 4 here, right? So likewise you will get TA power 4. So this is a very good case. So likewise you can solve lot of problems. Remember, the thumb rule is these two equations. In the place of Suppose you have this is about concentric shells. Instead, if you have concentric cylinders, long, infinite, long concentric cylinders. In that case, your F21 becomes A by B simply, because the area is 2 pi AL. Likewise, similarly, F22 becomes 1 minus A by B. Remember, this is for cylinder. And that is the topic of a view factor.